challenge they arrive, but this challenge is overcome here. This entire tissue, which is only a scaffold filled with the organ-specific cells of autologous, which we have derived in the lab, put it into bioreactors, incubators of your body, of your lab, and the organ develops with the function back again. 3D printings. This has got little challenges because mechanical powers, mechanical strength to hold the organ tissue together is a big challenge which we are still struggling to find how to get the mechanical strength of organ. Whereas the same deficiency has overcome by decellularization technologies. Now there are guns which have come for healing. If there's a deep wounds, you can just use epithelial cells with the matrix and patient can walk out with no wound. Can you imagine? With no wound, you can walk out in the daycare procedures. See the plasticity, application of the cell. It is beyond. This you can see the gun applying. The deep tissues are filled up. Right? So you can see the injury filling up with the gun. Epidermal cells. The same scaffolds can be used to develop soft tissues to the cartilages. Put them with the cell components. Put in the incubator. You can develop your nose, ear, cosmetics, whatever you want, turbinates, anything. Again, I need your help. This has been done in many of laboratories. Some of the technologies which we have signed recent contracts to bring in India, I would like to show some of the beautiful things. This is cellulization I spoke. The kidney organ is very complex, has got more than 70 types of cells. But to get into all these kind of cell components into different functions is very difficult. But decellularization can bring in that because the microenvironment helps cells differ into specific type of cells which we cannot do in the lab. So this is again what it is a bioreactor of its own which differentiates cells. The kidney itself has the environment which can cell differentiate into podocytes, nephrons and all of that. This is a tissue engineering, like you can see the cell, biomaterial, scaffold or scaffold and cell with all cytokine growth factors. You can develop tissue substitutes, like you can have chicken and mutton developed in the lab now. You can develop the muscles in the lab and have your dishes of non-veg food also. It's being done and it's been a future for all of you. We don't have to kill animals no more. These are little tissue engineering procedures. I may not take a long time because I know people are looking at me because I'm taking a lot of time. Now this is one technology, tissue sheet engineering, cell sheet engineering, which we have recently signed a contract with Japan to bring this technology in India, where the two-dimensional sheets are developed in the lab. These two-dimensional sheets can be taken multi-layered to make three-dimensional. Now these multi-layered three-dimensional sheets are again a breathing entities. A failing organ, I have put a proposal, I'll show you what I'm doing it now. In this, what we do, our recommendation is these sheets you can just attach to a failing organ. And the body takes up completely, like liver, hepatocyte, multi-three-dimensional sheets. Just put on the liver. Liver will take up the amalgamation of it, new caps, automatically will develop. There cannot be a better bioreactor than your body. Any lab cannot develop any bioreactor which is better than your body. You can imagine this body is a very good bioreactor. So we use that to create an environment by making a combination of two technologies. You can have liver, you can myocardium, pancreas, periosteum, cornea, ear, whatever is there, you can design. The sheets will make wonderful world. This is one which I'll show you just what we are doing. It is the cartilage, this which come as a, this is again FDA approved drug. This has been approved in Japan, which we have signed recently contract with this team. This is one team where I have been recently last month Japan, where I have signed a contract to get this technology in India, first time in India. Similarly, NK cell technology, we have NK cells in the body, first defense system for innate immune system, first defense innate immune system. You can imagine they are designed, except virus, everything they can kill. Your mutated cells, cancer cells, bacteria, everything they can kill. Just use them, modify with IL-2, IL-4, and induce their potential to 1,000 folds. This is the Osaki method, which we are recently signed with Select Corporation STEMRF to get this technology in India, particularly for developing NK cell technologies for treating solid tumors. Now, there are technologies which are coming like CAR T cells, which I will show you subsequently, how tissue engineering can come into picture, cell engineering can come into picture, genetic engineering rather, where these cells specifically designed against specific cancer antigen of the cell, CD19, can be differentiated to target those CD19 cells of hematopoietic stem cells, hematopoietic cancer cells. Now, leukemias, myelomas, and the combination of NK cells and CAR T cells can definitely make you, I may not say you will be cancer-free, but quality life, apart from chemo and radio and any other conventional methods, will be very, very different. I assure you, will get additional lives, which will be giving a quality life. You may not be completely cured, I agree, in advanced cases, but whatever you get, 2 year, 3 year, 4 year, 5 year, is a quality life. Now, this is what the basic mechanism, I may not describe right now because time is a big concern. The CRISPR-Cas technology, again, CRISPR-Cas9, again, one of the beautiful plastics, plasticity of the cell, the enzyme Cas9, particularly, that is using by some kind of carriers like, you can say, adenovirus, lentivirus, or you can use chemical carriers, you can use physical carriers like transcript, this one, electroporations, you can use it like, ultrasounds, you can use it like, for delivering these kind of genetic biomaterials in the cells to change the cell and make particularly genetic diseases, particularly genetic disease, you can have wonderful results in Duchenne's muscular dystrophies. You can have, there are coming up beautiful technologies of CRISPR technologies. Even they are now coming in the cancer treatments where we can have, this is called as precise gene editing, particular genome editing. Very precisely, specific location, we can design target and edit that particular gene to what you want to make that cell function. Old dogma of fixed neurons is changed to a higher plasticity of the brain, again biological plasticity, you can imagine. We have been taught in the medical schools where we studied neurons are fixed when we are born and they dry away, die away. That is why we get aging diseases, right? That has been taught to us. Response and plasticity to young children is very high. Your neurons are continuously interacting with the environment. You are all learning new skills. I believe you all are learning new sciences. At 50 years you learn dances, art you are learning. How do you learn? Without developing new connections in the brain. Because you develop new connections, you can learn something because there are two centers which are connecting each other, giving your ability to learn that specific processes, specific technologies. So brains are highly plastic. This is now beyond poor technologies, and you can see the migration of the cells which take place with new connections are taking throughout your life. That's a burning, you call them as burning effect. Neural growth, which is at birth you have got 100 times, rather billion times more neurons than adult. But those connections which you don't use, they disappear. These are temporary connections. Where you become permanent connections, they are going to give a lifetime concerned learning processes. So brains are highly plastic. Then similarly, infertility of dogma, which was taught to us like fixed number of eggs, they, with each ovulation, they disappear and they have, you go into an infertility, is no more existing. Again, the stem cell model has proved that ovarian stem cells are in the ovarian epithelium. Because the environment dries away, they don't function. If you give a proper environment, these fixed number of pool doesn't exist, and if you, this is an experiment which is done in a lab where the ovarian epithelial cells were taken in the lab and environment was given and they could differentiate into ovomes. Now these stem cells in the ovarian tissue obtained from a 60-year-old woman spawn different into oocyte structure, just change the environment. And this one more cell which is, probably you may not come across much of the reading because this one recent has come up, very small embryonic stem cell like cells in the human bone marrow are present. These are highly plastic like embryonic cells again. Now this is one I would like to put you on a very newer technology which is going to bypass iPSC cells or embryonic cells. This is called as TNT, tissue nanotransfection technology. Tissue nanotransfection technology, that's a DNA chip, which we have probably signed recent contract with, and the government of India has recommended for us this. I'll show you a small video of this. Nano chip could reach.
Only about the size of a cufflink, the device itself is small, but what it could represent is enormous. In this laboratory at the Ohio State University Wexner Medical Center, researchers demonstrate the concept. Simply place this chip on an injured part of the body and apply a small electrical current.
This process only takes less than a second and is not invasive. And then you're off, the chip does not stay with you. And the reprogramming of the cell starts. Technology is not just limited to be used on the skin. It can be used on other tissues within the body or outside the body, so on and so forth. So skin is only one example.
That reprogramming turns skin cells into nearly any type of cell doctors might need to treat a patient. A breakthrough technology in regenerative medicine.
Can you imagine the plasticity of the cell? A DNA chip is a silicon base carrying a cargo of biological material. You don't require a laboratory, you don't require an operation theater, you don't require an OPD procedure. You put on your hand, a somatic cell will differentiate into neurons, will differentiate into hepatocyte, endothelial cell. What you want, you have to change the cargo of biological material in the chip. It transfers that cargo into the cell. And as I said, there cannot be a better bioreactor than your body. This is a bioreactor for you. You don't require a GMP grade laboratories here. Can you imagine how many things we are bypassing here? We are bypassing so many gadgets, so many technologies. And the best part, this technology, the government of India has recommended for us for this compassionate trial in India to be conducted at STEMRx under the guidance of AIMS. I have demarcated particularly that word AIMS is going to guide us to start this technology in India. Now this mentor, Dr. Sen, is a mentor for me who has taught me stem cell technologies, and I have been frequently visiting these technologies to learn at Ohio State University. Future relation of medicine, I hope biological plastics have changed your thinking process today. Conclusion, I have thought a lot about stem cells, and I'm sure that when the historians look back at 20th century, the greatest scientific achievement will not be from the field of space technology or a computer technology, but will be from the tissue engineering and genetic medicine. 1999. Then was spoken. Today, as I said, you are a part of billionaire trillion world of biological plastics. These are certain research papers we keep on regularly publishing. The PubMed published one, neurogenic bladder. These are some avascular nets or patented technology where we have sure grade 4 regeneration of the cartilage of the new head of the femur. These are clinical trial approved by the WRU Western Institutional Review Board for avian. This is a patent for avian for us, which we have put a patent for avian technologies. Then non-healing fractures, research paper published by us, collaborations of or with different kind of clinical trials. This is one Prodigy standby unit, which is Asia's first unit in India, where this is standalone GMP grade facility. You can make any type of cell, CAR T cells, NK cells, MSCs, myocardicytes. What you talk of cell is a cell-designed computerized unit. You don't require a GMP, it itself is GMP. Now, recently we were regarded in Paris for our work, and these are certain recognitions, publications, and most important, I had a presentation with President of India for cancer therapies. This is the Montague, who is a Nobel laureate for HIV, the Chandra Sen, who is part and parcel of my STEMRx, where we had with Naddaji, my presentation with cancer treatments. This is my training program in US. These are my colleagues in whom I have worked. This is my training certificate. And most important, last, beyond hope, as we constantly strive towards future, we find technology and scientific breakthroughs moving us towards a direction that was never imagined. Biological plastics will change our life. The ongoing discovery of stem cell treatments has given a rise to a new techniques of treatment and a new way to control our lives. Stem cell therapy, biological plastic, has emerged as one of the most exciting and gifted fields in biological science today. Advances in this cell therapy will give us ability to merge our wellness so we can live a fuller and healthier life with a new hope. The journey through stem cell treatment is an exciting one as it will enable me to help people live their dreams. Thank you, dear friends, for patient hearing to me. I believe the biological plastics are going to be new phase of medicine. If anyone has some questions, I welcome. Thank you.